Welcome to our lesson on statistics part 2. So we are doing statistics 2, majorly form 4. Now, we want to focus on the above. Statistics 2, we want to focus on the above. Mean from assumed mean, variance, standard deviation. The good news is that the formula are in the table. So standard deviation from the formula there, you can get standard deviation from variance. Variance is the one which is shown. Okay, variance is shown. So standard deviation is the square root of variance. Standard deviation, if you know the relationship, then you can easily get it from the formula. They didn't show exactly standard deviation, but remember, standard deviation is the square root of variance. So here in the table there is variance, and I've given you the formula that is given there, but there are three. Okay, so I'm not dwelling on this. It's important you know the formula and its application. So today I'm going to do the very first one. Okay, and the data I'm dealing with is ungrouped data. So I have 11, 15, 21, 23, 25 and 31. So from this data, which could represent any quantities, maybe you could be told their sizes of shoes, maybe their heights of seedlings, and so on. But if we want to get the variance, we want to get the variance here, okay, of this ungrouped data. What do you do? From the first formula, if I may rub this, the very first formula says what? It says variance is equal to sigma f into x minus bar x, and then squared over n. That is the very first formula you see in your table. If you master the formula vis-a-vis data given, you move very fast. So if this is my formula to get variance, if I get variance, remember I will get standard deviation. So they are intertwined. There are around three things that we are learning. One, mean, then variance, then standard deviation. Okay, so I'm starting with the ungrouped data because that is the basis. An entity X is given. Okay, so from this formula, what do you need to create? Remember, X are the values given. These are the values given. So we are interpreting the formula. Then bar X is mean. Bar X is mean. Okay, then there is an operation subtract, and there is another operation square. N is the total frequency. N is total frequency. The total number of items. 1, 2, 3, 4, 5, 6. So already I know the frequency, the total number of frequency is 6. The formula requires you to have X here. I have the values of X. I've written them here. Okay, those are the values of X. If I was given grouped data, you get the middle. So I'm done with x. X will always be given, or you find it in case of grouped data. So I'm done with x. How do we get mean? Mean is always sigma fx divided by n. Okay? So like this is simple. What is the mean of all these numbers? Okay? You could have created just f. 11 is appearing once, so f is 1. 15 is appearing once, so f is 1, and so on. But in short, the mean of these numbers, I add all of them, which gives me 126, divided by n, which is 6, you get 21. So we know how to get the mean. We know how to get the mean there. Okay? So remember, this is bar x. I know x, I know bar x. I know x, the components x. I know even f is 1, 1, 1, 1, 1, 1. I know x. I know bar x. If I may write it in red, I know bar x. So what operation? That this bracket requires me to subtract x minus bar x. The data minus me. So look at, focus here now. The data given minus mean. So 11 minus 21, you get negative 10. 15 is value of the next value of x. I subtract 21, I get negative 6. The next value of x is 21. 21 minus 21. Okay? You get 0. 23 is another value of x. You subtract the mean, which is 21, you get 2, and so on. So this is the first operation in the formula. X minus bar x. X minus real mean bar x. So there is a difference when you are writing your work. There is x and there is bar x. You cannot change. They have different meaning. Okay. So we concentrate now on the second operation, which is square. The values you have here, you are asked to square them. So everything will be positive. Negative 10 times negative 10, 100. Negative 6 times negative 6, 36. And so on. So these are the basic components of the formula. So you are trying to segment the question. Chop it into small manageable pieces. Okay? I know the values of f. All those entries are appearing once. So f is 1, 1, 1, 1, 1, 1. So multiplication by 1 does not change that original value. Right? So this now is the component that you require. I am not doing f. I'm not doing f into x minus bar x squared. I'm not doing this part component because f is 1. So this can help me get that. Okay? So I am done with that. Now we focus on the formula. This is the formula up there. I've rewritten it. Sigma f x minus that squared. So we substitute. We want to substitute. So this is the sum. Get all products. All products. Remember, x minus bar x squared are these values here. If you multiply each of them by 1, because that is the meaning of f. If you multiply 11 was appearing once, so its F is 1. So 100 by 1, 36 by 1 does not change, 0 by 1 does not change, 4 by 1 does not change, and so on. So I want to get now the sum of all these products. All these products. So you can do it even often. This is 100 and 100 is 200. Okay? It's 200. Then what else do I have? I have 4 and 36 is 40. So 240. Add 16, 256. So we have 256 divided by 6. What does it give me? 42.67. 6 is recurring to 4 significant figure. That is the answer. Okay? That's. Now, suppose we move a step further. Second formula. Second formula in your book. The second formula is here. Sigma fx squared minus bar that. So we are saying another formula, the second one is sigma fx squared over n minus bar x squared. That is the way the formula appears in the table. Okay, this is the way it appears in the table. So we concentrate here now. What are the components mean, which we know? So somewhere we shall be doing the operation square. So the component are these letters here. They are the ones you must create first before you come to the formula. Create them. Bar x. Okay? Bar x. We add 21 as bar x. So to square it is very simple. Come here. X is supposed to be squared. So I can create here x squared. Can we create here? Yes. Let me use blue. X squared. So this is 11 when you square 121. Okay? That is 121. This is 15. If you square it is 225. This is 21. If you square 21 is 441. This is 23. If you square 23 it is 529. This is 25 squared, 625. And what is 31 squared? 961. Okay? So I'm trying to do formula number 2. Formula number 2 is written here. Okay? It is written here. What do I need from you? To understand that these are letters that you create. You produce them. They are already there. Produce them. So start from here. This is bar x. That is the mean. Get the real mean. Add fx divided by n. But fortunately we had already found it was 21. So I already know this. I keep it. I come here. It says x squared. X are those entries you have. Okay? So you square each. After squaring each, you multiply each square by its corresponding f. In my example, f is 1111. So after getting x squared, when you multiply by 1, those values do not change here. So if I take 121 multiply by 1, I'll be getting the whole of this, okay? That's why there is no need to do it again. If your frequency is 1, this will operate as this product. But if your frequency is not 1, then you have to create another row or column for this product. Okay, so this is the formula, second formula. Understand how to get it. So we go to finish this work. Okay, we have to add all of them. 121 plus this plus that plus that plus that plus that. That one you do it using calculator, you get 2902. Divide by my n, which is 6. Then subtract 21 squared. Okay? When you do that, you get the same answer. So, what I'm really trying to show you is that the formulas which are given in the table, you have to know how to use them so that you take less time and concentrate on other questions. Passing is in your hands. If you want to pass, you pass. If you doubt to pass, the result will be doubtful, and so on. Do this again on your own. Start with the formula number 1, then you go to formula number 2. Then do formula number 3. When I'll be doing that example, when I'll be doing example 3, formula number 3, I will be doing using another setup. But you do formula number 3 using the same and see if you will get 42.67. We have concluded that if you analyze this, you will still get 42.67. Maybe you will just differ on the fourth figure. Hardly third figure. Fourth figure, yes. Hardly third figure. You can't differ with the 42, the first two figures, no. Okay? So try again. Understand the formula and how it will be useful to you so that formula does not become a headache. The question is a headache. Now you have double headaches. Remember, subscribe so that you see whatever I put in. Okay? Then my email address will get you. Okay? Bye bye.